Welcome to the Math Corner.
Don't you just love primes?
Prime ribs?
No, prime numbers.
Why should we even care about prime numbers, Taylor?
Well, Jenny, prime numbers are natural numbers with only two positive factors being 1 and themselves.
I mean, yeah, but what does that mean to me?
I mean, they're not composite, and 1's not prime.
Okay, what else?
2's the only even prime.
Again, why should I care?
I mean, cybersecurity, cryptography.
Could you elaborate more on that, Em?
Sure. Prime numbers help us encrypt pretty much everything. The first ingredient required for an encryption algorithm are two large prime numbers. The larger the numbers, the safer the encryption.
How so?
Take two very large numbers that are relatively prime and multiply them together. That way, it's hard to find the resulting number used to encrypt personal information because the only factors are the primes and 1.
But yeah, how's that safer though? Well, can anyone detect primes?
Yes, they can, and let me show you.
This is Euclid's proof of the infiniteness of primes. This is a very important property, so keep it in mind. Now we're going to talk about primality tests. The most simplistic primality test, in my opinion, is to take your number n and square root it. Then check to see if any of the integers between 2 and the square root of n evenly divide your original number n. If they do, then n is not prime. Let's do an example with the number 54,321. The square root of this number is somewhere around 233.06, so we need to check all of the integers between 2 and 233. This could take a long time, so let's try and learn a couple divisibility tricks that might make these processes a little less painful. The first thing I did was establish that my number is not even. In this case, our number ends in a 1, so we're good. The next trick to learn is divisibility by 3 or 9. For this one, it's really fun because you take all of the digits and add them together. So in this case, we have a 5 plus a 4 plus a 3 plus 2 plus 1. This gives us 15, which is divisible by 3, and thus the whole number is divisible by 3. Also making our number not prime. But let's keep on going for the sake of education. The next number you could try is divisibility by 5. So if your number ends in a 0 or 5, then it's divisible by 5. Kind of a given, but it's a fun trick to note. The final number to try is divisibility by 11. For this one, you're going to take all of the digits and alternate the signs between them. So add, subtract, add, subtract, add, subtract. In this case, it's not divisible by 11, but these are fun tricks to learn because they work on any number, no matter how big or how small. So go ahead and give them a try. This is a JavaScript program we created to detect primes in pink and twin primes in blue, which are prime numbers that neighbor each other. Remember that proof of infinite primes from earlier? Well, a big question is whether twin primes are also infinite. So see, there's still a few unknowns, and despite massive efforts, there is truly no efficient formula for factoring large numbers into primes. Modern encryption algorithms exploit that fact. Also note, most individuals looking for primes are mathematicians, not hackers. So in essence, your personal information is still relatively safe.